So we have completed the addressing modes. Now we will see some programming examples. Now before learning how to write a effective program, we must know the instructions of 8086 processor. What we will do, we will take some examples of program. Whichever new instructions come during the programming, so we will learn those instructions. Now instead of just going through all the instructions in one go, I think it is better approach while programming. Whichever new instruction will come, we will discuss about that, then we will write the program. So first we will go with a simple program. Suppose data transfer program. Suppose we want to transfer the data which is inside the memory and again in some new memory locations. Now suppose, let us assume that this is a memory area. Now in this memory area, let us assume this is our data segment area. We will extend this somewhat more. So this is our data segment memory area. So in total, this is 64 KB memory space in data segment. And to initialize the base address of our data segment, we will use segment register. So let the value of our segment register is 2000H. And the offset address of any location inside this data segment. We can use the various methods, various addressing modes to give the offset address, right? We can use the direct addressing mode, in which we can give the offset address of our data immediately with the instruction, or we can use register indirect addressing mode, where we can use the register BX, DI and SI, which we can use for mentioning our offset address of our data in data segment. So there is one convention to write the segment address and offset address, and convention is like this. If we write like this, 2000H colon 1394H, right? So here whatever we write before colon, that is the segment register value. And whatever we write after colon, so this is our offset address. So if we say in our data segment we are having some data at address this 2000:1394, at this address in data segment we are having some data. So this implies that 2000 is the value of our data segment and 1394 is the offset address of our data in the data segment. So we will use this convention. This is a convention which we use in 8086 programming. So now in our this data segment, let us assume we are having three 8-bit numbers stored at three different offset addresses, and let us assume these offset addresses are 1000H, another offset address is 1001H, and another offset address is 1002H. So this is the first address of our data segment, offset address, that is 0000H, right? After some time we will get this offset address, these offset address, these offset address, and at the top last offset address will be FFFH. So at each memory location we are having some 8-bit number. So our aim here is whatever data we are having, you write here data, at 2000H:1000H, at this offset we are having some data. Let us assume it is 39H. We want to move data of this address to 2000:1010H. Okay. So 1010H offset address we will find somewhere here. Here. This is 1010H offset. So we want to transfer the data which is at offset 1000H to 1010H, 1010H here. And data of address 2000H:1001H, this we will want to move at new memory location, that is address 2000H:1011H. So 101, this is 1010. The next location will have the offset 1011H. So now the data which is at 1001, let us assume some data 9A. So this 9A will be moved, we require it to be moved from this offset to this offset at 1010 here. Now our third data, which is at address 2000H:1002H. So data at this offset will be moved to 2000H:1012H. 1012H will be the offset address of next to 1011. This is 1012H. So at this offset, we want to move data which is at 1002. Let us assume the data is F3H. So this F3H, we require it to be moved to offset address 1010H. Like this. Right? So this is our aim. So now how to write this program? So what we will do? First, we will write this program in the simplest way, right? In the simplest way. Then we will convert it in more effective manner. So first I will write the instruction move AX, 2000H, which is this 2000H is the value of 16-bit value which we have to load in data segment register to initialize our data segment register. Since we cannot write this instruction move DS, 2000H, this instruction is invalid because immediate value, right? Immediate value we cannot write in any segment register. That's why first we will load this value in AX register, and from AX we will transfer it to DS, data segment register. So now next instruction will be move DS comma AX. Now what we will do, the offset address, the starting of the offset address of our source data, which we want to transfer, which is here 1000H and 1001H and 1002H. These are the offset address of our source data. So we will use now, we can use a register or directly also we can use. So now what instruction I will write? Move. See here ultimately what we want that at this offset we want to transfer the data 1010H, right, from 1000H, right. See, if we write the this 16-bit value inside bracket, this indicates that it is an offset address, right. If we remove the bracket, this indicates this is a data, right. So this is a difference between the address and data. And if I write this instruction, move within bracket 1010H, comma within bracket 1000H. So this is the offset address of my source, and this is the offset address of my destination. So what basically we want, whatever is at offset address 1000H inside the memory, this has to be transferred to a new offset address inside the memory 1010H. But it is not possible to transfer the data inside memory directly, right? So directly to transfer this data from here to here inside the memory is not possible. So what we have to do, first we have to bring this data inside our microprocessor. Once it is inside our microprocessor, then we can transfer that from microprocessor to new memory location, right? So that is the process. So in this particular instruction, what do we want? We want to transfer from memory location to memory location. So this is not possible, right? So this instruction is invalid because source and destination both cannot be the memory locations in any instruction. Only one of our operand can be the memory location. Either we can use the memory location for our source, or we can use for destination. For the both source and destination, we cannot use the memory. So this instruction is not valid. So what we will do, first we will bring the 8-bit number inside our microprocessor and we will store it in some 8-bit register, right? Because this is the 8-bit number which we want to bring. So I will write the instruction move AL, comma, within bracket 1000H. So this is the example of direct addressing mode. And what is the purpose of this example? A 8-bit number will be transferred. How we come to know that 8-bit number will be transferred? So you just see your destination register. This is AL, which is a 8-bit register. So this will indicate us that there is a data transfer of a 8-bit number, right? Now from where data will be transferred? The offset address of our data is 1000H, and in case of direct addressing mode, the default segment is data segment. So this offset address belongs to our data segment, which is means in data segment we have already stored 2000H. So now data will be moved from data segment whose address, initial address, first address is stored in data segment register, basically higher 16 bits of the base address of our data segment is stored in data segment register and offset is given with the instruction. So now with this instruction, what will happen? The AL register will get a value 39. So now from the memory, we have brought the data inside our microprocessor in 8-bit register AL. Now from the AL we will transfer it to the new offset address 1010H in the same data segment, right? So here I will write the instruction move within bracket 1010H comma AL. So now with this instruction, the value of AL will be transferred to this offset address, right? And default segment is data segment. So inside the data segment, the value will be transferred and you will find at 1010H offset, you will find 39H has been transferred. Now we have to transfer second 8-bit number which is at offset address 1001 to new offset address at 1011H. So we can follow the same process. Move AL comma within bracket 1001H. Now with this instruction, the data at the offset 1001 will be moved in AL. So now the value of AL will change and it will become 9AH. And now once the data is in AL, we will transfer it from AL to new offset 1011. So now move 1011H comma AL. Now our second byte has been transferred. Same way we will transfer our third byte. So for this, move AL comma within bracket 1002H and move within bracket 1012H comma AL. This 1012, right? And in the last we will write the instruction HLT, right? HLT means halt. So when the program will come across the opcode of this instruction, then it will stop. So in this way, we can transfer 3 bytes. So basically, microprocessor is a sequential machine, right? Microprocessor is a sequential machine. Means it will execute the instruction in a sequence, one after another. Means first it will execute this instruction. So once processor will get the opcode and the opcode of first instruction inside the processor, then the value of IP register will be increased, right? IP register is instruction pointer. So which specifies or which points the offset address of our code, right? The offset address of our code. So now it will increase and it will point the next instruction. First instruction has been executed, now second instruction will be executed. After this, the IP will point the third instruction, then it will point the next instruction. In this way, the processor is a sequential machine, right? But there is a mechanism by which we can change the sequence of our instruction. Regarding that, I will just come to that topic after some time. So now we come back to this program. So now here you just observe one thing. To transfer 1 byte, right? To transfer 1 byte from one location to another location, basically we require 2 instructions, right? First, this one. We require 2 instructions. First, from the offset 1000, that is this data. First, we will bring that data inside some register of microprocessor. Then in the next instruction, from microprocessor we will transfer it to some other location of the memory. So we require these two instructions to transfer 1 byte. Now these two instructions we require for transferring another byte, second byte. These two instructions we require to transfer third byte, right? So if we are transferring 3 bytes, 2 bytes, 5 bytes, then it is okay. But now you just assume if we want to transfer 100 bytes, right? There are 100 bytes stored from the offset address 1000. From here 100 bytes are stored in a sequence and we want to transfer these. So if we follow this approach, then what will happen? These set of instructions we have to write 100 times. Then we can transfer 100 bytes. Means total these type of 200 instructions we require. Right? Because 2 instructions are required to transfer 1 byte. So to transfer 100 byte we require 2 into 100. 200 instructions are required. If we are transferring 1000 bytes, then we require 2000 instructions. So this approach is not a proper approach as a programmer, right? So we shall write a program in such a way so that it should consume minimum instructions, right? Because ultimately, if the number of instructions will increase, then finally each instruction will require the memory location where it has to be stored. It requires the memory, right? So if the number of instructions will increase, then the size of our program code will also increase. So we have to just write a program by thinking that the number of instructions or number of bytes in a program should be minimum, right? So in next lecture I will discuss how to write an efficient program for the same problem.